Hello, everyone. Welcome to today's live broadcast, Improving Methodological Quality of Animal Experiments. Are we doing all we can? I am Brenda Kelly Kim of LabRoots, and I'll be your moderator for today's event. We are delighted to bring you this educational web seminar presented by LabRoots, the leading social networking site for science professionals. For more information, please visit www.labroots.com. We have a few important announcements before we begin. This webcast is designed to be interactive, and we encourage you to ask questions during the event. You can submit your questions by typing them in the Q&A box, which can be found by clicking on the green Q&A button at the lower left of the presentation window. We'll try to answer as many of your questions as we can. You can enlarge the slide window by clicking on the screen icon in the lower right-hand corner of the slide window. If you have any technical problems viewing or hearing this presentation, please click on the support button at the top right of your presentation window, or submit your problem through the green Q&A button, lower left. I would now like to introduce today's speaker, Dr. Nuno Franco. Nuno Franco is a biologist and postdoctoral researcher at the I3S University of Porto Laboratory Animal Science Group and an external advisor for laboratory animal science at the University of Lisbon's IMN. His research focuses on laboratory animal welfare, along with ethical, legal, social, and scientific issues in animal research. His research interests also include translational science, science communication, and education. He is currently setting up a national network of animal welfare bodies in Portugal. I'll now turn it over to Dr. Franco for his presentation.
Thank you, Brenda. Thank you all for attending this presentation. So I'm talking about self-regulatory mechanisms regarding animal research and how these have contributed to improve principles in practice. And I'll address some current issues with this self-regulation. So a very quick overview of this presentation. I will start by addressing the issue of quality of research as an ethical imperative. So the main factors for the conditional acceptance of animal research, the current state of the art regarding animal use based on my previous work. Poor translatability as a cause for opposition to animal research, and this is why we should address it as much as we can. And of course, reproducibility as a condition for translatability. Then I'll move on to address the issue of poor methodological quality and what we have been doing to tackle it. And I'll close my presentation by giving a few remarks on how to deal with this systemic problem in a systemic fashion. So we all know that the advent of scientific medicine is intrinsically connected with animal research since at least the 19th century. So vaccines, antibiotics, insulin, anti-cancer agents, anesthetics, you name it, all of those benefits from medical research have resulted from proper use of animals in science. It's quite revealing that 82% of all Nobel laureates in medicine and physiology since 1901 have been given to researchers using animals, and this includes all Nobel prizes since 1984. But as you all know, animal research is an ethical issue. However, there is a current social, legal, and ethical view on the acceptability of animal research, which is based on a cost-benefit perspective. And by cost, we mean by the harm we put on animals. But this is a mainstream position that is far from being consensual, and there is a considerable public debate about animal experimentation. So we as scientists working with animals, we are working under a social license. This license is tacit rather than deliberate, but we should have in mind that using animals is more of a privilege than a given right. So, and this privilege warrants that the public trusts that our work is relevant, competent, and ethical. So I'm going to give you a very quick overview of how the public forms animal research, and this will be important on the justification of why we should do all we can to improve the benefits from animal research and minimize harm. So we have two main initial attitudes, which are approval and disapproval, of course, and the key factors are harms to animals and the benefits of research. The thing is, there is a part of society that focuses largely or solely on harm. So there is no value conflict, and we can't do anything to convince them otherwise. So these will remain disapprovers. And then we have on the side of those who approve, conditional approval. So no one approves of animal research, giving a carte blanche to researchers. So this approval does warrant that no alternatives are available and their animals are respected. It might happen that some of the disapprovers, when faced with more information and with a few case studies where harm and benefit are in conflict, might shift and become more reserved and approve on animal use on a case-by-case basis. And this might happen also with those who start out by being approvers, and then when they do know that there are some issues with animal welfare and with the translatability of animal research, so those who are initially approvers can become reserved as well. So it's always conditional, the acceptance of animal research. So it must aim at gaining scientific knowledge, improving health and safety of humans and other animals, of course, and it warrants that all efforts are made in order to minimize harm to animals, and of course that these conditions are duly enforced by legislation and adequately supervised. So starting from the first premise, are animal experiments benefiting human health? So it's hard to argue from what I just said. Animal experiments do not contribute to human health, but there is evidence piling up that most animal research does not translate into clinical benefit. And even worse, most animal research is not reproducible because of unaccounted biases. So roughly 90% of compounds that are deemed promising in animal studies will fail clinical trials. This might be due to a number of causes, but the chances are it's more than just one cause. So it includes publication bias, methodological shortcomings, some problems with species differences and construct validity issues. But the thing is, we cannot know how informative a given animal model is until we eliminate the noise caused by methodological problems. So should we mind the model or the method? I'm giving you an example which is taken by a large study that involved around 18,000 animals carried out by the Amyotrophic Lateral Sclerosis Therapy Development Institute. They retested over 50 drugs, almost 60 drugs that were deemed quite promising in preclinical trials, but failed miserably in the clinical setting. But they did so properly. What they found, and this is the effect that had been reported in the literature, what they found when they carried out adequately powered, properly randomized blind tests, that the effect was simply not there. So does this mean that the animals were such good models that if we carried out the experiments correctly, they would mimic the clinical setting? Well, it doesn't work the other way around. So the thing is, we don't know. We just don't know. We just have this huge confounding factor in the bias of animal experiments from methodological problems that prevents us from making an informed assessment of the translational value of these models. One of the problems is the underpowering of experiments. We all know that the power of an experiment is the probability of finding an effect if the effect is indeed there. If there is an effect, and because of low power, we fail to detect it, so animals will be wasted. And the group size should be determined on a case-by-case basis. A very quick example, if we have a two-group comparison by a test, and we are seeking a 30% increase in survival, we observe there is a standard deviation of 40%, and with very standard conditions of 80% power and an alpha of 0.05, the recommended group size would be 23 animals. But this largely used number of, almost magical number of 10 animals, which is quite arbitrary, for these conditions will only give us a 50% power. So we have 50% chances under these conditions that if there is an effect, we wouldn't find it. And the problem is, in the neurosciences, the mean power is between 8% and 31%. And this is indeed a problem. And moreover, because with such low power, when we do find an effect, chances are this effect will be exaggerated. And then when we try to reproduce the experiment, it will tend to give more modest results or even no results at all, which we call the winner's curse. So we definitely need more power in animal experiments. Just a shout out to all the Star Trek geeks out there. Another issue is lack of random assignment of animals to groups and blinding to the outcome. So not all animals are created equal. So if we don't randomize the animals to the treatment groups, we might end up having cage effects or litter effects or any given effect that is given by any characteristic which is shared by the first animals that we pick up and put in a group and the last animals that we pick up and put in another group. Another problem is blinding observers to the scientific outcome and to the experimental groups and the control groups. And these have been reported to have an effect of up to 20% on the outcome. So this is by Van der Wop et al., was published in Brain, and they measured the reported improvement in infarct volume in studies that had randomized animals to groups and in studies that had carried out blinded assessment, and they did find there was a bias that was evident. So we are not accounting for this in most of the published literature. When Bevarta et al. Carried out a systematic review of 290 animal studies that had been published in the proceedings of a conference over the years, they found that non-randomized, unblinded tests ended up reporting 90% of positive results when we properly randomize and blind the outcome. Only 68%. So there is a large part of the effect that is reported that is resulting from these unaccounted biases. So let's move on to the second premise, that animals are treated humanely. I'll just make a very short presentation of my previous work. I carried out two systematic reviews, one on animal models of Huntington's disease and another one on murine models of tuberculosis. Two very different diseases, but the results are quite the same. What I found in the literature was that there was a significant rising trend in papers reporting ethical approval protocols or the following of animal care guidelines. But when I went on to classify the severity of these studies, and you see these dotted lines, they mean level 4 studies, which under the current legislation would be deemed above threshold, because animals are allowed to die spontaneously of the disease or reach a comatose point, we don't observe any significant change over the years, and moreover, it was more likely that a very severe study had been approved by an ethics committee than otherwise. So 42% of studies classified as level 4 had reported ethical approval. Most of them had allowed animals to die spontaneously. And for the Huntington's disease case study, 57% had reported ethical approval of level 4 studies. You can know more about these studies and these papers published in PLOS ONE, ATLA, and PLOS Pathogens. So what does this mean? Firstly, that we are far from making all efforts to minimize suffering, and this is a sentence that we see recurrently in the literature, but chances are it's meaningless when we actually look at the methods and how it was carried out. And also that we are sending the message that it's okay to allow animals reaching end stages and dying from the disease, and second, that ethics committees approve of studies being done this way. So there are actually reasons to be concerned about how and why animals are used in science, and it does become difficult to argue in favor of animal experiments from a scientific and ethical point of view if the public has no clear understanding of what benefits may result from it, what is being done to minimize harm, and how is this regulated and supervised. And I present this issue in this paper on ATLA. And this is quite important because in Europe we had over 1 million signatures for a European Citizens Initiative to stop animal use. They called it Stop Vivisection. It was supported by several members of the European Parliament, and the petitioners rejected the 3 R's, all of the 3 R's, because they considered they legitimize animal use, and they demanded a repeal of legislation. And we are talking about arguably the most advanced legislation to protect animals used for scientific purposes. It also means a shift in the approach by anti-vivisectionists from violent attacks and targeting of scientists to lobbying and trying to work within the corridors of power. And another important factor was that rather than focusing on harm, they were focusing on semi-scientific arguments regarding the usefulness and the informational value of animal experiments. And although it was rejected by the European Commission, they are far from finished. So they do state that they will carry on pursuing all civil, political, and legal means to stop animal use, regardless of the benefits that might be gained from it. What we mean by benefit, this is almost a quasi-philosophical question, but the thing is, we already have some mechanisms for the evaluation of benefit. We have the evaluation of funding applications that ultimately will judge whether a given animal experiment is worthy of funding or not, and we of course have the peer review of manuscripts for publication. Potential excuse me, benefits are much harder to explain to the public, for instance in basic research. And the thing is, the unwanted biases and the low quality methods in science are hindering the likelihood of benefit even further. The European Commission proposes that potential to achieve the intended benefit is considered one of the factors when evaluating animal projects. And if you see here this last square, the third one on the right, you will see that even if the intended benefit is high, and the harm to animals is low, if the likelihood of benefit is also low, so if there is no methodological quality that will ensure that we will gain sound data from the study, the project should not be approved. So this is important. What mechanisms, regulatory mechanisms, do we have to help us address this issue? We are all acquainted with external regulation. We have legislation, we have in Europe, and I apologize for being so Eurocentric. We have European directive, we have national law, which is the transposition of the directive, and we also have funders. We do not tend to see funders as external regulators, but since they do give a value and give funding based on meritocracy, based on what they perceive is a valid use of animals, they also act as external regulation. Internal regulation starts by us, by individual scientists in our own choice of species and methods, and also as the scientific community as a whole. So when we are peer reviewers, when we follow journal policies on animal use, when we write or follow community guidelines on animal use, we are self-regulating. And then we have mechanisms that are a mix of the two, because they are legally imposed, but ultimately carried out by peers. And we have, in this regard, project evaluation and training of researchers to carry out animal experiments. We have two projects running here at our lab. One of them is focusing on external legislation, which is the framework project funded and impact. And the other one is my own postdoc grant, which is focusing on internal regulatory mechanisms and their impact on animal research. When I talk about methodological quality, I'm talking about both the soundness of the experimental design and the respect for animal welfare. And both of them can be improved by self-regulation. So let's focus primarily on scientific community's guidelines on animal use, and taking the ALS community as an example. The purpose of guidelines from the scientific community can be more directed at animal welfare, and these include guidance documents by charities such as the RSPCA or UFOR, or other sections of the scientific community. We also have guidelines on the quality of reporting, so you can integrate the results from animal experiments into systematic reviews and have a larger assessment of the evidence for, let us say, of drug efficacy, and also to have a better understanding of the results that are presented. And then we have guidelines to improve the scientific soundness of the result, and these include general guidance on experimental design, on statistics, on broadly used techniques, and guidelines that are more field specific, such as the guidelines from the ALS community. Knowing about the pervasive effect of poor methodological quality, two sets of guidelines have already been published by the amyotrophic lateral sclerosis research community, one in 2007 and another, an update, in 2010. Very quickly, amyotrophic lateral sclerosis is a rapidly progressive and fatal motor neuron degenerative disease. Most patients will die between 2 and 5 years after the first clinical signs. The incidence is 5 times higher than that of Huntington's, and every year 11,000 new cases appear in Europe. It's characterized by increasing muscle rigidity, muscle twitching, increasing and worsening weakness from the decreasing muscle mass as the motor neurons degenerate, and eventually difficulty speaking, swallowing, and breathing. The mouse model, the most common mouse model used is still the SOD1 G93A. It's a transgenic model with a mutation for the copper zinc superoxide dismutase enzyme, which is associated with around 20% of the cases of familial ALS. However, only 10% of ALS cases are familial and the rest are sporadic. So we have a construct validity of the model right there. The onset of disease in these models can vary from lab to lab, from strain to strain, and also the rate of progression. But roughly, by 120 days, you will find a gait abnormality, which will quickly move towards fallen paresis and complete paralysis of the hind limbs, and will move on to complete paralysis, which is the moribund stage, and then respiratory failure, as it happens in the clinical setting with patients. The standard endpoint, which is proposed in the guidelines, is the euthanasia of animals that can no longer resume the right position after being placed dorsally recumbent. I have a short video here just to show you these mice, so it doesn't become too abstract and you have a grasp of the motor difficulty of these mice. Could you please play the video?
These are 20-week-old mice bearing the SOD1 mutation and already showing paralysis of the hind limbs. SOD1 mice only represent a fraction of familial ALS cases, but their phenotype shares several similarities with ALS with different etiologies. I'd like to draw your attention to the orange mesh food on the cage floor to allow animals to eat and hydrate as they become unable to reach the food hopper. Not doing this will result in malnutrition and dehydration, becoming comorbidities that add noise to the outcome.
So we developed a purpose-made severity classification scale to classify the severity of these studies, where level 4 is roughly equivalent to the conventional endpoint. So animals are euthanized when they lose the ability to right themselves within 10 to 30 seconds after being laid recumbent, or when they lose 15 to 20% of the peak weight. And level 5, as those studies that would allow animals to die spontaneously or reach complete paralysis, which usually precedes death by a few hours. And these studies, considering the current legislation in the EU, would be considered the above threshold, so above the severe classification. So to understand the impact of these guidelines, we set out to carry out a systematic review of published studies on this model. And we collected data on self-reported regulatory compliance, on animal welfare based on the severity that animals were allowed to reach, the implementation of humane endpoints, and any other model-specific refinements, such as the adding of mesh food to the cage floor. We also looked at the quality of reporting, of methods of animals, housing and husbandry, and basic scientific standards such as justification for the sample size, randomization of animals to treatment groups, and blinding of observers. And to evaluate the impact of the guidelines, we reviewed papers published both before and after the publication of said guidelines. So we reviewed papers published in 2005, 9, 11, and 13. We ended up with more than 1,300 full abstracts after the first triage, and ended up being 797. And after the second triage, we found 382 full original research papers to review. This data was entirely collected by Joana Fernandes, who also carried out a lot of the analysis. Regarding reporting of relevant research parameters and good practices, we found that preclinical studies, which were the studies that were explicitly stated to be carried out to test a given treatment, were much more likely to report useful information such as number of transgene copies, sex of the animal, genetic background, group size, and justification for the group size, and especially for the random assignment of animals to treatment groups and for the blinding of observers. We did found that preclinical studies upheld much higher standards than proof of concept studies. However, although group size was highly reported, only 2% of the studies we reviewed justified the numbers used, and we were only satisfied with around 2 or 3 papers out of 382. So no good news there. Regarding group size, we found that 91% of preclinical studies, those who were supposed to uphold the highest standards, 91% of those use fewer or much fewer animals than the absolute minimum recommended by the ALS guidelines. But we did report an increase in self-reported regulatory compliance, especially the approval of protocols by an ethics committee or an equivalent. However, only 15 of the papers published after the guidelines explicitly stated following the ALS guidelines published by the scientific community. Severity was not at all affected by whether a paper was reported to be approved by an ethics committee. So if the study was approved by an ethics committee, we didn't find any impact on the severity. And most studies, either before or after the publication of the guidelines, use the conventional endpoint. So, but a surprisingly low percentage of them allowed animals to die spontaneously or reach complete paralysis. However, only 10% of studies where animals manifested overt motor dysfunction reported any enrichment or any cage adaptation to allow animals to eat and drink or even move. And neither time nor the regulatory compliance status appears to have influenced the use of these refinements. We did find some country differences in the incidence of highly severe studies. So if we look at these graphs, we'll find that neither in Canada nor in the UK, and surprisingly also not in China, no study was allowed to allow animals to reach a level 5 severity, and we found a high incidence of these level 5 very high severe studies in Israel, Japan, and Korea. So a brief discussion of these results. Only 12% of these studies were classified at the highest severity level, and the use of a single model is likely a factor in the broad dissemination of an endpoint. And however, this conventional endpoint was already broadly used before the first guidelines, so the guidelines reflected what was already common practice rather than proposing or promoting earlier endpoints. And it's revealing that self-reported regulatory compliance had no overall impact on severity. and we did find a higher severity of preclinical studies over proof of concept. And just a quick note on these standard endpoints, which are applied at very late stages. There are at least 2 papers reporting earlier endpoints that correlate nicely with later endpoints. So these could be applied, and future guidelines could contemplate these endpoints once they are more thoroughly validated. So regarding likelihood of benefit, the sample sizes were much lower than recommended. This is apparently in line with the principle of reduction, but only apparently, really, because underpowered studies might lead to unreliable results and ultimately to animals being wasted, as well as resources. We found higher methodological and reporting standards in preclinical studies, but the thing is, all animal studies should be held to high scientific standards. And the lack of cage adaptations is worrisome because it can affect results. You have the confounding effect of starvation and dehydration in survival data. It also allows to increase external validity because patients are provided palliative care. So it mimics more closely what happens in the clinic. So the take-home messages from this work is that the community guidelines have not yet influenced how research is carried out or reported, and other self-regulatory mechanisms must be in place to promote guideline compliance then. And these guidelines must uphold higher animal welfare standards as much as scientific ones, because, as I told you previously, even if the intended benefit is high, if there is low likelihood of benefit and great harm to animals, the research is unacceptable. So moving on to journal policies on animal use. Journals can be important regulators of how research is carried out and reported, because authors, scientists are motivated to publish their results, and this is particularly true for high-impact journals. So if high-impact journals lead the way in promoting in their policies animal welfare, quality of research, and improved reporting of animal experiments, chances are authors would feel more motivated to comply with such guidelines. Journals are increasingly adhering to guidelines on reporting of animal studies, and especially the arrived guidelines, but the editorial policies on animal welfare and ethics are much more diverse and even frequently absent from journal policies. But we wanted to map journal policies, so we picked up this acronym for excellence in editorial mandatory policies on animal research and developed the exemplar scale to classify editorial policies. The key features of this scale is that it ranges from 0 to 20, and that divides editorial policies into 4 main categories, namely regulatory compliance, quality of research and reporting of results, animal welfare and ethics, and a criterion for the exclusion of papers based on the other 3 criteria. For each category, we define a gold standard or an ideal criterion, which is worth 5 points. If journals did not observe that ideal criterion, the sum of alternative criteria for this category could award up to 4 points. And we decided that some items would have more weight on the final score than others. So if journals demand authors to give a proof that the study had underwent ethical approval or any kind of project evaluation, the policies from the journal will be given a higher score for that category than if they only ask authors to state compliance with relevant guidelines or legislation. for instance. An example from the completely bogus journal of biological stuff and whatnot, which has an example score of 9. What can we learn from this score? We know that there is no criterion for the exclusion of papers. So if authors do not comply, there is nothing explicitly stated in the guidelines for authors that the manuscript will be excluded. There is a high relevance given to compliance with regulations and some importance placed upon issues regarding quality of reporting and animal welfare and ethics. You can know more about the example score and its use as a tool to classify editorial policies in this paper published in Animals. So we set out to classify a sample of 170 journals publishing studies, animal studies on type 1 diabetes, tuberculosis, or ALS. We chose these fields because firstly, we think they are representative of a lot of the preclinical research that is being carried out, but also because we are carrying out systematic reviews of animal welfare and soundness of methods in these fields. So this will allow us in the future to compare the score of the journals and the principles in practice as revealed in the papers that these journals are publishing. 72% of the 170 journals in our sample were scored less than 8 points. Pardon me. And more than 91% scored less than 10. So there are a lot of journals that have very low demanding policies on animal use. If we look at this by category and field of research, we can see that for category 1, reporting of regulatory compliance, 92% of journals have some policy on the compliance to regulations by authors. When we look at quality of research and reporting, 72% of journals in our sample had no policy on this issue, and it's even more worrisome for policies on animal welfare and ethics and on the existence of any criterion for the exclusion of papers based on lack of compliance by authors. We didn't find any differences between fields, country, or journal antiquity, neither for impact factor of the journals. We did find, however, that open access journals scored significantly higher than subscription-based journals. So in short, most scientific journals are mainly concerned that authors just state compliance with laws and regulations rather than having an active role promoting best practice, and also that journals are disregarding their role in self-regulation of animal research and are diverting it to institutions and regulators. There is room for optimism, however, and this was information which was published this week, actually, that tells us that there is a surge in support for animal research guidelines, and specifically the derived guidelines. I'll just jump back to show you here category B, where we find a small spike here in this dichotomy between those studies, those journals that don't have any policies on reporting of data from animal studies, and those journals that have a 5 score, which was mainly granted to those journals that referenced authors to derived guidelines. So there is some effect of derived guidelines. and more than 600 journals now refer authors to these guidelines. However, there is no evidence that the arrived guidelines being referenced in the journal policies actually have an effect on the quality of the information available in the papers that these journals publish. So this is reason for concern. There is also room for optimism regarding animal welfare and attention to animal welfare issues. This very recently, in September 2015, Nature made the authors of the paper not retract but correct their paper based on a breach of their license. And they state that as well as writing to correct their paper to mark the breach of animal welfare guidelines, the authors apologize for the breach, and they are right to do so. Cases such as this could provoke a justifiable backlash against animal research. So all involved scientists, institutions, funders, and journals must do more to ensure that regulations are strictly observed. I actually consider this to be a big deal. Well, even though it followed a complaint rather than the editors or reviewers' initiative, even though no animal welfare concerns were identified during the correction of the paper, and even though the journal's general policies on animal welfare remain unchanged, they did change something very specific about maximum tumor size that authors are allowed to report, but nothing major. And compliance with regulations remains the central issue. And just to give you an idea of Nature's example score, which is 7, 2 for regulatory compliance, 5 for reporting of information, because they reference authors to the arrived guidelines, and no policies whatsoever on animal welfare and ethics aside from this later policy on tumor size, and no explicit policy on the exclusion of papers based on lack of compliance to journal policies. So future directions, there are a lot of self-regulatory mechanisms. I have already covered editorial policies and community guidelines. But due to the issues that we found, we are carrying out a survey to editors on their views regarding the policies and the interplay between policies, the role of the editors and reviewers regarding animal welfare ethics, 3Rs, and quality of research. We also carrying out a systematic review of type 1 diabetes models, so we can cross the information between the policies and the actual standards as reported in the papers. And regarding self-regulation, what else can we do? So scientists have a role in project evaluation, of course, in training other researchers in animal use, and when we are reviewing papers for scientific journals. And this will affect researchers' choice of species and methods, and back and forth. So it's a dynamic interaction between regulation and principles and practice. So change comes from within. So what I propose is that everyone should educate themselves on sound experimental design. A good starting point is this website by Michael Festing. It has an old school vibe, but it's a very well structured and easy to comprehend site, and you can learn the basics on experimental design, sample size calculation, and you would be good to go. And you also have some quizzes to self-evaluate, and I recommend it vividly. I urge you to review your own methods and make sure your students do too, and them especially, because we are not born knowing how to design and analyze scientific experiments, also called for microfasting. If you can establish regular training in experimental design in your institute, the best one I can think of is the one which is carried out by FRAME, the courses on reduction and experimental design by the Fund for the Replacement of Animals in Medical Experiments, which, despite the name, focus on all of the 3 R's, so replacement, reduction, and refinement. I suggest that you take a look on this paper by Dr. Derek Fry on how to teach experimental design, how to develop courses that can go from an afternoon to a 3-day course or a doctoral program module. And I urge you to apply these standards when you peer review. So be demanding regarding animal welfare and refinement, the detail in reporting. So if there is no sufficient information regarding animals, husbandry, experimental design, the hypothesis that is stated, statistics, sample size requested from authors, make sure that the authors did what they should do to, or should have done, to avoid bias by randomization, by blinding, by declaring also conflicts of interest. But being demanding does not necessarily mean rejecting manuscripts. Why is it so? Well, firstly, this is what we think authors do when they reject a manuscript, that they will give up, and they acknowledge that the manuscript has several flaws, that they should have done things differently. But what actually happens is that they will just try to submit it somewhere else, somewhere that will have lower standards. So it's much better to be constructive. So if important information is missing, request it. If authors did not randomize or do not report randomization of blinding of observers to the outcome, they should report it so. And chances are, in some cases, you'll find out that the authors actually did that and didn't just fail to report it. Regarding animal welfare, if there are major concerns, do ask for the license documentation. If the animals were given palliative care, or if cage nesting or any adaptations, this should be reported. And also, if not, so we can have an informed assessment of the survival data. If animals endure unnecessary harm, discuss this with the editor. Regarding scientific soundness, if the sample size of the methods are flawed, suggest more conservative conclusions and discussion of study limitations. So in a nutshell, regulation and supervision of animal use are important and necessary, but obviously they are insufficient. The same goes for the ethical appraisal of animal experiments. But it would be impossible and objectionable to have researchers under permanent scrutiny. So we can't, and in my opinion, we shouldn't have a policeman in every lab. So each researcher must also become its own regulator. So are we doing all we can to improve the methodological quality of animal experiments based on the data that I presented to you? Well, not really. But we can do much better. And it's only through researchers' responsibility, both as individuals and as part of a community, of a large extended community, that significant progress can be achieved regarding the humane treatment of lab animals and the reliability and reproducibility of animal research. We can't expect animal data to be translatable to the clinical setting if we can't even ensure that we can replicate it in other animals. So reproducibility must precede translatability of animal studies. And no single solution will do the trick, because we are part of an ecosystem, so we have to address what I consider to be a systemic problem systemically. I just urge you, because animal rights activists and people wanting to stop medical research are focusing more and more on the methodological shortcomings on animal research and the lack of translational value, I urge you to please don't make them right. And also, as someone who is deeply involved in talking to the public, in the media, with students in schools, and I have a blog, I write in newspapers. Just today I had an op-ed in the national newspaper on animal research and pros and cons, and advocating for humane and scientifically sound animal research. I urge you to please don't make me wrong. So a few acknowledgements, of course, to my postdoc supervisor, Anna Olsen, to my co-supervisor, Peter Sando, and Raquel Martins, who carried out a lot of the analysis for the journal policies review, Joana Fernandes, who did most of the work for the ALS case study, all of my group who pitched in when needed, the Unimpact team, the Portuguese Society for Lab Animal Science for all their help, and of course these two granting bodies, the FCT and the FP7 framework, for being kind enough to give me money to carry out my research. And thank you for listening.
Thank you, Dr. Franco, for that informative presentation. Before we get started on our question and answer session, I want to remind the audience how to submit their questions. You can submit questions for Dr. Franco by typing them in the Q&A box, which can be found by clicking on the green Q&A button at the lower left of the presentation window. We'll try to get to as many questions as you can. This was a great topic today about animal welfare, lab animals, and experimentation. We know you probably have a lot to say. We'll just give you a few seconds to find the green button, type in your question, and Dr. Franco will be happy to talk about anything you have comments or questions on. Okay. I think we must have some questions coming in from our audience here in just a few minutes. Okay, perhaps not. Perhaps our audience is onto another one of our presentations. I would just like to thank Dr. Franco again for his time today, bringing us this important presentation. This webinar is going to be available on demand on labroots.com through August of 2016. Attendees today will receive an email alerting them when this webcast is available for replay, and we would encourage you to share that email with your colleagues. I want to just turn it back over to Dr. Franco for any final comments you might have on his presentation for our audience.
Well, I just wanted to thank you all for attending, and if you have any pressing questions, do contact me to my email that you can find in the left right corner, and I'll be glad to reply. Thank you.
Thank you again, Dr. Franco. I'd also like to thank labroots.com for making this web seminar possible. We hope we see you again in one of our presentations. That's all we have for today. Thank you very much and goodbye.